Hey, in this video, I'm going to show you how to hack the default firmware that we left off with in the first video to create your own modes from scratch. So this is the endpoint that we're going to reach in this video, and you can see it's a pretty neat effect where you have the LEDs growing along each side and then shrinking away. Let's get started. Just picking up where we left off in the last video, we've programmed a very fast rainbow mode, and I'm just going to copy all of that code from the previous video into a new particle app. So select all with Control A and copy, then go to code, and I'm going to create a new app. And this time I'm going to spell infinity correctly. And I'll call this infinity hack. And we can give it a description if we like. Let's make a mode. And I'll choose to paste all that code in, go back to the top, and I should be able to, I have to hit enter on that. Okay, so now we have a new particle app with exactly the same code as the last sketch. Now remember, I do have to include that NeoPixel library. So we'll just go to the libraries, select NeoPixel, and include in project. And we're going to include it in Infinity Hack and confirm that. So of course, Particle has been kind enough to drop in that include statement. I already have it again, so I'll just remove that, just to remove the redundancy, and we're ready to go. Now remember, to get your Infinity Kit to connect to Wi-Fi, you have to press that setup button at the moment. And that's handled by this line of code here. So semi-automatic means that the Infinity Kit will basically work straight away without any Wi-Fi connection. But because we're going to be uploading code to it a few times in this video, I'm going to change this to automatic, which means it'll always connect to Wi-Fi. And in fact, it won't run the onboard sketch that we write or the onboard application that we write unless a Wi-Fi network is present. But that'll just streamline things for this video. All right, with that housekeeping out of the way, we're finally ready to create our own mode from scratch. So I'll just scroll down from there, and the first thing that we have to do is say that the state exists. This line, enum state var, this is basically our way of telling the photon on board, these are some states that exist. I'm going to use the word state and mode interchangeably. So we can see that these look kind of familiar. We have rainbow, we have comet, something called solid and scroll. So these are the existing modes or states that are built into the Infinity Kit. And if we want to add our own, we just need to give it a state variable or a state constant here. So I'm just going to include a new line and call this state edge, because, you know, we're lighting up edges in sequence. I don't know, for want of a better name, edge will do for now. So that's our way of saying, hey, this state exists. What enum does is it enumerates a number for each of these names. So rather than refer to, say, mode 1, 2, 3, and 4, because we're humans, we want to refer to them by, meaningful names. And this is a way of attaching a name to a constant number when we don't really care what the number is. We want to refer to some constant number, some arbitrary number by a name. You'll see what this means later on. I'm just going to gloss past the remaining global variables. They're not super important for now. And just going past the setup routine, this is code that's run only once to set up the Infinity Kit. We can see that something called strip begin is being called. That's basically initializing the strip of LEDs. And then update is updating the state of all the LEDs. And because they haven't been set yet, they're just being initialized to an off state. So that's just the, startup housekeeping. Moving down to the loop, this is code that runs continuously. So let's take a close look at what's going on here, because this is what drives the Infinity Kit. We have a user color. So we can select our user color with that color scrolling mode. That's basically kept in this user color variable. So it just needs to be initialized, and it gets initialized to some value off a color wheel. We run a function called Wi-Fi or connect Wi-Fi on button press. So that's the pressing of the setup button this is what handles connecting to Wi-Fi when that setup button is pressed. Now, this is the important part. We have some variable called state gets set by a function called getState, and that is being passed our potentiometer. So looking at it from 1,000 yards, moving the potentiometer affects the output of this function getState, and getState sets the variable state. So when we come down to our the switch case statement, we're switching off state, and state is being set to something. What's it being set to? It's being set to those predefined values that we saw in the enum call. So this is how we determine what state we want to go into. We set state to one of those variables, or one of those values, sorry. So let's flesh this out a little bit just to illustrate. Our new state is called state_edge. So we can just create that declaration in the state machine here by saying case state edge. That means that if getState returns state edge and it gets written into the state variable, this is the part of the code that's going to be called. And what we can do here is just call some function that doesn't exist yet, but we're going to write it very shortly. So we can call our new mode. Our new mode, we're just calling edge. So I'll call some function called edge, and we'll pass in the user color. And then break. Just following the pattern, basically following the pattern of the existing states. We have, if state is equal to state edge, then run the edge function and break. So now we've made some state or mode exist, and we can actually enter it in this state machine. What remains to be done? Well, of course we have to create our mode for one. We have to, write the functionality for it. And we also have to update the getState function so that it can actually return state edge. So let's do that next. Just going to scroll down into the functions area, and you'll find probably the second function down is the getState function. So what is actually happening here? Well, again, looking at it from 1,000 yards, we've got this if-else chain, and we're basically comparing val, which is something to do with reading the potentiometer value, and we're just seeing if it's less than a certain amount. So what's happening here is that we're reading the value of the potentiometer and then dividing it by essentially the maximum number that could be returned. So what that means is val is going to take on a value between 0 and 1, and that just describes the fraction of turn that you've put on the pot. So 1 being all the way to the right and 0 being all the way to the left. Rather than try to expand this if-else chain, for now I'm just going to have the edge function replace the comment function. So we'll essentially be swapping it out. So what I'll do is comment out that line. I've done that the hotkey way. I've pressed Control and then slash, and that's how you can quickly comment or uncomment lines. But you can comment it out just by inserting those 2 slashes, and instead of returning state comment for between 75 and 95% of the pot's arc, I'll return state edge. So what have we achieved so far? We can return the state that we want to get at a certain point in the pot's revolution, which is super important because now the only thing we have left to do is to build the functionality of our new state. Now we need to actually write our new mode. We need to give it that functionality. So remember, from this switch case statement, we're going to call a function edge, and we're going to give it a value, which is the user selected color. This is something that's common to a lot of modes because we want to be able to select a color and have that be used for lots of different modes if we wish. So I'll come back down to just under the get state, and we'll put our new function here for now. So we're going to, our function is going to return nothing. It's going to be a void edge, and what's going into it is this unsigned integer 32-bit. We're passing in some color. Now, if you take a dive through a lot of the other states, you'll see this thing called state current equals, and then we're setting it to whatever state we're inside. That's just a good bit of housekeeping so that you can quickly update, so that the photon knows which state it's currently in at any given time. And that's a little bit important because for when we have, say, these long loops, I'm looking at the comment state as an example. When we have these long loops, we can insert a check that basically says, is the pot still pointing to a region that's inside that state? And that way, if we didn't have that, then we'd be able to move the pot and we'd have to wait for some long loop to finish before it would leave the state. If you haven't really followed along with that, don't worry. Just suffice to say that including state current equals state edge is a really good idea. Okay, so what do we need to do? We want to light up all four edges of the mirror, kind of grow them on, and then shrink them off, I suppose. So we're going to need to know, first of all, how many LEDs are there per edge? So let's create a variable for that. I'm going to say int edge length equals, and this is where we can invoke the strip property. So I kind of glossed over it before, but at the top of the code, we initialized the LED strip, and it created some object called strip. Now, we initialized that LED strip with some number of LEDs. There are 44 LEDs, so we could refer to this variable as the total number of LEDs. But I'm going to pull it off the strip object itself. So I'll say strip num pixels. That's Adafruit's built-in functionality. And that's the 44 LEDs that make up the entire Infinity kit. So because we have a square mirror, it stands to reason that if we divide that by 4, that is the number of LEDs per edge, which should be 11. So what comes next? We're going to work off a single edge and then kind of replicate it across all 4. Because once you have the functionality for one edge, it's really simple to get it working on all 4 edges. So just thinking about one edge, we need to grow along that edge and then shrink along that edge. And we can do that with a for loop. So I'm going to create a loop index for int I equals 0, and then I is less than edge length. That's the number of LEDs that we care about. We're going to increment I. So what do we want to do in this loop? We basically want to set the ith LED each time it iterates, and then push that change to the strip. So we're going to call the set pixel function. We're going to set the ith pixel, and we're going to give it the user set color. I haven't really gone into how this works yet, but suffice to say, the first argument is the index of the pixel you want to set and the color you want to set it to. And remember, this color is coming in as the user-defined color that's being passed in. So we want to update that LED. Now, setting the pixel doesn't actually make that change appear on the strip. To make that change appear, we have to call something called update. This means that we can set as many pixels as we want in whatever order we want. And then once we hit that update function, that's when the changes get pushed to the LED strip. And so that things don't go crazy, how about we delay for 50 milliseconds? All right, we've come a long way, so let's just hit that flash button, making sure our Infinity kit is connected. Hit that flash button and we'll see what happens. But just before we proceed, one thing that I forgot to include was a useful debugging tool, which is the clear strip function. So all we're doing in this function is updating pixels, but we're not actually clearing any, which means that any residual pixels that are left over from any other function are just going to remain static. So we need to include that just to give us like a blank canvas to work off. So once you've included that, then you can hit the clear strip function, the flash button, sorry. Let's see what effect that code change had. So here's our very fast rainbow mode. And if we move across, we then have, I guess that's the color scroll mode. And then the next one would have been the comet, but now we have that growing edge. Remember, we've only entered the code that makes the edge grow, but making it shrink is also really easy. We're just, rather than setting the LED to a specific color, we now just set it to off. So the shrinking along one edge is also really easy to implement. Let's implement that and see how it works. What we can essentially do is just grab this for loop that we've written for the growing along a single edge, and copy it and paste it in, because we're going to do a very similar operation, but rather than write it to some user-defined color, in this case it was a purple because I'd played around with that color scroll mode. What we can set it to here is strip.color, that's without a U. And then now we have the red, green, and blue values that we want to set it to, which is 0, 0, 0, because that's going to turn the LED off. So with that simple change, let's just hit the flash button to make sure that we have everything working for a single edge. All right, so the photon has rebooted, so it's gone to that default color that it starts up with, which in this case is green. You might remember it comes from the color wheel 0. But we can see along a single edge, this is the 0th LED to the 11th or 10th, I guess, if you're indexing from 0. We're growing and then shrinking. So that's one loop running and then the other. One to turn them on and then one to turn them all off. And you can see that because we only did it for I is less than edge length, it's only doing it for this first edge. Now it turns out to get this behavior to mirror across all 4 edges is a really, really simple addition. This may not be the most elegant way to do it, but it's certainly very clear. So if we take this one line, copy it and paste it, let's work on as if we're setting the second edge. That's like saying we want the ith LED of the second edge to work. And because the LEDs are addressed as one long string, that's just like offsetting by edge length. And then if we wanted to do this same thing for the 3rd and 4th edges, we could say we want to offset by 2 times the edge length, and no points for guessing correctly here, 3 times the edge length. So we're basically doing that same edge operation, just offset by the length of a single edge. So we're offsetting around all 4 edges. Now I'll very quickly include that change in the second loop as well. And now that all that is complete, we don't really need this clear strip routine. We technically don't need that because we're kind of clearing all the LEDs ourselves. So everything looks okay here. Let's hit that flash button. Of course, this isn't the most elegant or programmatically correct way to do this. You can see that there's quite a lot of duplicated functionality. This could be very easily achieved with another loop, but it's also really easy to see what's going on. Okay, that code's flashed, and you can see that the behavior of one edge has been replicated across the remaining 3 edges. And that completes writing our own mode completely from scratch. Now, there are a few really big things that I glossed over very quickly in just trying to get this video to an endpoint where you can kind of copy the existing structure and hack it to create your own modes if you want to. For the finer points, definitely refer to some of the written material for this tutorial about the more exact function of each thing we just covered. And don't forget to look through the comments of the code as well, because it kind of leaves this trail of breadcrumbs for you to follow. And there's one last thing that I forgot to include, and we kind of set up the groundwork for it before, but if you take the mode knob off this mode just as it starts, it has to actually complete both of those loops before it will respond, which can be a bit confusing for the user. So we're just going to update that. And you might remember that at the very start of the edge function, we set the current state to state edge. And this is for the functionality that we're about to include. So I'm just going to scroll down to comment because the line is actually an exact copy. If we grab this last line that says, if and in English, this is kind of what it means. If the current state that the pot is set to is not equal to the state we're in, then leave the state. So this is what we can drop into our loops, and it kind of polls that potentiometer to just check if we actually want to exit this loop prematurely. because we don't need to be in it anymore. The user is requesting to be off it. So it doesn't really matter where exactly this goes. You can see in one I've put it above the delay, in the other I've put it below. It doesn't really matter where it goes. It kind of makes sense to put it in, I guess, towards the bottom. So I'll do that here. But if you include those lines, then you should get instant feedback when you leave that state with the knob. So there you have it, creating your own mode from scratch. Now, I'd love to see what you, the creative internet community, comes up with. So if you come up with your own mode, absolutely, we'd love to see you post some code for it in the forums or even upload a little demonstration video. That'd be awesome to see. I'll catch you next time.